Hello, so today we are talking about confidence intervals for proportions. So proportions are one type of confidence interval. We could also make confidence intervals for means, which is going to be in the next video. But today we're sticking with proportions. Remember, proportions are p and p hat. So we have my population proportion and my sample proportion. We're going to be dealing a lot with this notation today. This is section 8.2 in your textbook. Go there to follow along and to see other examples worked out. So let's imagine that I have this giant barrel of beads, just this huge barrel of beads, and I want to know what proportion of the beads are orange. I'm a big Clemson football fan. I want to know what percent are orange because I want to make an orange necklace. So suppose I take a random sample of 175 beads and 28 of them are orange. So I have this huge barrel. I take a random sample of 175 and 28 of them are orange. Well, if I think about what I can do with that data, I can find p hat, or my sample proportion, which is 28 over 175. And that gives me a sample proportion of 0.16, or about 16%. So if I think about this giant barrel and my one sample, does that mean that there's exactly 16% of the beads are orange? No, that's just one sample. That sample gave me this proportion of 0.16. So we think about samples, we have the center, but then we also have a spread. So it says, what about the spread? Thinking about how often would I get 0.16, or are my samples going to vary from 0.16 and give me a spread to my sampling distribution? So we've talked about spread a lot in this class. Spread goes with standard deviation. And if I think about finding the standard deviation, I'm going to use this new formula, so get this formula down. It's p hat minus or times 1 minus p hat. Before, we've seen p and 1 minus p, but I don't know the proportion of the population. I only know p hat, so my standard deviation, or my spread, is going to be for this statistic, and it's going to have p hat times 1 minus p hat over n, and it's the square root of that. So we have our center, which is where I take my sample, and it's going to be centered around 0.16, but the spread, or how varied my samples are going to be, comes from this formula, the standard deviation of the statistic. So that brings us to key point number 1. Sampling has variability. We've talked about variability. It refers to the spread. And the standard deviation measures the spread or variability within a sample distribution. So this is review of standard deviation, but we're coming back to this key point because this is going to set us up for how we find our confidence interval. So if we think about standard deviation, we have to remember that in order to use that formula for standard deviation, this has to be true. The population has to be at least 10 times as large as my sample. Well, if I think about that condition, we're going to start calling this a condition. In order to make a confidence interval, this condition must be true. And actually, there's 2 other conditions that must be true as well. So conditions for a one proportion confidence interval, there's 3 conditions. And it's funny because we've actually talked about all 3 of these throughout this year. The first condition is the random condition. So the data has to come from a random sample. We also sometimes see that as an SRS, a simple random sample, from the population of interest. So whenever I'm reading a problem, I need to see, is it random? Does it say that somewhere in the problem? Or does it say SRS? And if it does, that condition is met. The second condition is my normal condition. Well, we've talked about for proportions to be normal, n times p hat has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or equal to 10. This condition tells me, is my sample large enough? So I want to see, is my sample large enough? Do these conditions get met? If they do, I can give a check off for normal. So random is stated in the problem, or it says SRS. Normal, I check with these two conditions, or these two formulas, which we've reviewed before and have actually used the last two chapters. Remember, there's no central limit theorem for proportions. I can't do that n is greater than or equal to 30. That's only for means. The last condition is what we just talked about, the independence condition, or that the population is at least 10 times as large as my sample. If this condition's met, I can use that standard deviation formula. So we have to check these conditions, and I have to list them to justify my use of inference and to justify making an interval. So you may be wondering, okay, we've talked about these three conditions. We've talked about standard deviation and p hat. How do I actually make an interval? How do I go through the process of making a confidence interval and finding that window? Well, we have 4 steps to make a confidence interval. These are the same steps for every interval. So we're actually going to use the state, plan, do, conclude steps until April. These are going to be the same 4 steps we do in every problem until April. So make sure you write these down, and we're going to go through them one by one in context of this problem. So state, identify the population and the parameter, which we've been doing in our do nows and in class. Step 2 is to state all the conditions. So we have to state those 3 and verify that they're met. Step 3 is to actually make the interval using this formula, the point estimate plus or minus the margin of error. And step 4 is to conclude. And in my conclusion, I need to say, what is my interval, connect it to the problem, and give some context. So let's do the state plan steps together. So we're going to go back to the giant barrel of beads. I want to make a 90% confidence interval to estimate the proportion of orange beads. So I lowered my confidence from 95%. I only want to be 90% confident. It says we take a random sample of 175 beads and 28 of them are orange. So it's the same context as before. If I think about this state step, I need the population and the parameter, or pop and para. So the population are all the beads in the barrel. We've talked about the population is the all. So population, all the beads in the barrel. But the parameter, or what we're looking for, is the proportion of beads that are orange. So this would be a complete answer to the state step. Notice there's context, and it talks about population, and then what am I trying to estimate? I'm trying to estimate the proportion that are orange. So state is done. Plan, I have to go through my 3 conditions. The first condition is random. In the problem it says random, so that's met. The second condition is normal, which is the n times 1 minus p and n times p greater than or equal to 10. So if I think about the normal condition, n is 175 times p is 0.16. Remember we found that by 28 over 175. So n times p greater than or equal to 10. Well, 28 is greater than or equal to 10, so that one's met. And then 175 times 0.84 greater than or equal to 10. And when I do that, I get 147. greater than or equal to 10. And that's met. So random, it says random in the problem, that condition's met. Normal's met. Independence, it talks about a giant barrel, so I can assume that there's more than 10 times 175, or I can assume that there's more than 1,750 beads in the barrel. So we've done two of my steps, the state and the plan. The next step is the do step, which is where I actually make the interval. How do I calculate an interval from scratch? So we've been given the margin of error up to this point, but now we're going to calculate it. If we think about the key point from the last video and what we just saw on the do step, all confidence intervals follow this format, the statistic, which is p hat, or x bar, plus or minus the margin of error, and we said this changes for different types of intervals. So for a one proportion interval, this is actually the formula that I'm going to use. If I break it down, p hat is my point estimator, or my sample proportion, my statistic, plus or minus the margin of error. So this margin of error consists of two pieces. The critical value, which we call Z star, times the standard error, or my standard deviation. So we've seen this piece before. This is my spread. This is the standard deviation. I checked the condition to make sure I could use it, and we've seen p hat, but this Z star is the critical value associated with a confidence level. And you may be thinking, how do I find Z star? Well, Z star is found on the t-distribution table that you actually got in class today. So you got this table, and I said, use this in the video. This is what I was referring to. So Z star is found at the very bottom of the table. It's the last row. And you see it says confidence level, and it gives me all these different levels. You will never be asked a confidence level besides the ones that are on here. So you see 95%, the Z star is 1.960, 90%, Z star is 1.645. So I'm just going to plug in one of these numbers, and I'm going to choose the number that's associated with the confidence level that I want into my formula. So Z star is just one of these numbers. You find it by using the confidence level given to you in the problem. I also have a note that sometimes you'll see it written as infinity at the bottom of a table. The table you got has Z star, but sometimes if you found another table online, it would have infinity. So let's actually do the do step. So if I think about the do step, it's p hat plus or minus Z star times the square root of p hat times 1 minus p hat over n. Well, we found p hat already to be 0.16. We know that n is 175, and Z star for 90% confidence, because the problem told me 90, is 1.645. So when I plug these numbers in, I get 0.16 plus or minus 1.645 times the square root of 0.16 times 1 minus 0.16 over 175. And when I do that arithmetic, I end up getting 0.16 plus or minus 0.046. So be really careful when you type this into your calculator, go line by line, and then you get 0.16 plus or minus 0.046. So this is actually an okay interval. You could leave it like this, or if you wanted to do the plus or minus portion of it and actually get your bounds, 0.16 minus 0.046 gives me 0.114. So when I do the subtraction, I get 0.114. When I do the addition, I get 0.206. So this is my interval. Well, if I want to write this in a conclusion, we would say we are 90% confident that the true proportion of orange beads is within the interval of 0.114 to 0.206. If you like percents, you could also say, or 11.4% to 20.6%. So we're 90% confident that the true percent of orange beads is between 11.4% and 20.6%. So that's a wrap. We can construct confidence intervals using the state, plan, do, conclude steps. So these 4 steps, like I said, are the same for every interval. We're going to get really comfortable with them. And Z star is found on the t-distribution, the very bottom of that table, and it determines how wide the interval is. So this is section 8.2. You can look on there for extra examples and for your homework problems. See you next time.